Today we're doing day 3 of section 11.2, finding limits. So for our first example, notice you're giving a cubic function for f of x and you're given a constant function for g of x. And the first problem they would like you to calculate is to find the limit as x approaches 4 of f of g of x. So this is called the composition of the two. So remember, this means the g function is being plugged into the f. And then later on when we do g of f of x, it's vice versa. So here, just to kind of give ourselves some room, when we do the first one, so I have to plug g into f, so I have the limit as x approaches 4, and g is going to get plugged into f, so essentially I'm going to have 3 cubed plus 3 squared minus 6 times 3 minus 1. So the limit as x approaches 4, we're going to get 27 plus 9 minus 18 minus 1. So 27 plus 9 will put us at 36. This is minus 19. So the limit as x approaches 4 is going to be 17. And since this is constant, the answer is 17. Okay, so remember, no matter what I plug in, notice there's essentially nowhere to plug x in, so the answer is just going to be 17. I have a y value of 17. Now for the second one, the limit as x approaches 4 of g of f of x, well, when I go to plug f of x into g, notice there's no input, so the answer is going to be 3 when I find g of f of x, and again, this is constant, so the answer would just be 3. So that's a pretty easy one. So let's try another one. So here we have the limit, or f of x equals x squared plus 9. It says find the limit of the inverse of f. So remember, to find the inverse of f, we set these two things. We change f of x to be y, and then we switch x and y. And then we get y by itself, so I'm going to start by subtracting that 9 over. And then to get y by itself, I take the square root. So I have y equals the square root of x minus 9. So now I'm going to go back over here, and I'm finding the limit as x approaches 25 of the equation, the square root of x minus 9. So when I plug that 25 in, I have 25 minus 9 equals the square root of 16, and then the square root of 16 is 4. So the limit, actually I can just write it over here, so the limit as this goes to 25 will be just a solid 4. So again, pretty straightforward as long as you know how to find the inverse, so you plug in the value that you're approaching. So one more for today. So again, we're going back to compositions. Now we're dealing with fractions. So I have f of g of x for my first one. So I'm going to not rewrite limit every single time just to save some space. So this will become 2 over, and this x is going to be the spot for input for the g function, over 6 divided by x plus 3. And we keep change flip, so I keep the 2, and I'm timesing by x plus 3 over 6. This 2 and 6 can kind of reduce to be 1/3. So at this point, I'm now at the limit as x approaches negative 3 of x plus 3 over 3. So when I plug in negative 3, I get 0 over 3, and I know 0 over anything is 0. So this first one is going to be equal to 0. So now for my second one, I'm doing g of f of x, so I'm plugging f into g. So I have 6 over 2 over x plus 3. And I want to get common denominators in that bottom. So I'm going to change this 3 to say 3x over x. So now I have common denominators. So now this will become 6 all over 2 plus 3x over x. So again, the whole point of getting common denominators is so I can add these together. Now I want to keep change flip, so I have 6 times x over 2 plus 3x. So this will become 6x over 2 plus 3x. And now the limit is approaching -3, so I'm going to plug -3 into both of these values. And let me actually get myself a new screen. So I'll have 6 times -3 all over 2 plus 3 times the -3. So in the numerator we get -18. In the denominator I have 2 minus 9. So I have -18 divided by -7. And that doesn't divide evenly, but I know two negatives make a positive, so I would say that this is 18 over 7. If you wanted to do improper, or this is improper, if you wanted to do mixed, you would say 2 and 4/7, or you could put it as a decimal. So here's just like kind of an extension of what we learned yesterday. It's just different properties, so it kind of refreshes your memory on inverse and composition.